بسم الله الرحمن الرحيم. Assalamu alaikum wa rahmatullahi wa barakatuh. Our chapter today is about the range of a function which is defined algebraically. Now let's go on to activity 2. The same story, we have a table that should be filled in. This is curve C1. The sense in this case is strictly decreasing. The domain is from 0 close to plus infinity, it's semi, and the range is from minus infinity to closed 1, which is also semi. Well, curve 2, it's also a strictly decreasing curve as you see here. The domain is from negative 3 to negative 1, closed, and the range is from negative 2 to negative 1, also closed. Curve C3, it's strictly decreasing. The domain is from negative infinity to negative 1, semi, and the range is from 0 closed to 1 opened. Remember 0 closed because 0 in this case is attained, and this is semi. And finally with C4, it's also strictly decreasing. The domain is from negative infinity to 0 open, and the range is also negative infinity 0 open. Now what can you say about the continuity and the sense of variations? We can also state here that in all cases f is continuous and strictly decreasing, as you see. Let's see whether we get the same answers or not as activity 1. What can you say about the nature of I and f of I? We can also say here that I and f of I have the same nature. So if f is continuous and strictly increasing, or f is continuous and strictly decreasing, we can say that I, the domain of definition, and f of I, which is the range, do have the same nature. Now let's discuss some of these curves. Referring to curve 2, this is curve 2. What relation exists between negative 3 and negative 1? Remember, this is negative 3 and this is negative 1. It's from the other side of the interval. In this case, we can say that f of negative 3 is negative 1. Now, referring to the same curve, what relation exists between negative 1 and negative 2? This is negative 1 and this is negative 2. So f of negative 1 is negative 2 graphically. Let's continue now. If we refer to curve 3, this is curve 3. What relation exists between negative 1 and 0? This is negative 1. You can see negative 1 on the right side of the interval, 0 on the left side of the other interval. We can see that f of negative 1 is 0. Now, referring to curve 1, what relation exists between positive infinity and negative infinity? This is positive infinity, this is negative infinity. You can see that the limit of f of x as x tends to plus infinity is negative infinity. Okay, now here we have the table of results for activities 1 and 2. Remember, if f is continuous and strictly increasing, then we can say that I and f of I have the same nature, and this happens also if f is strictly decreasing. Now let's see here, if we have a closed interval AB, its image would be f of A, f of B, whereas if we have a closed interval AB here, its image would be f of B, f of A. We have to flip the boundaries in case f is decreasing. Now if we have a semi-opened interval which is closed at A, opened at B, its image would be f of A and the limit as x tends to B minus in case f is increasing, whereas its image would be the limit as x tends to B minus of f of x and f of A if f is decreasing. So in the case of a strictly decreasing function, we always flip the boundaries of the image, and similarly for other cases. Now let's see if this works if the function is not strictly monotonic. Well, we have this curve which is C1. According to the sense of variations, it's sometimes increasing, sometimes decreasing. Its domain is from negative infinity to positive infinity. It's open, and its range also is from negative infinity to positive infinity, which is also open. Now this is another curve which is C2. It's also increasing, decreasing. its domain is from negative infinity to positive infinity, whereas its range is from negative infinity to 4 closed. Now, what can you say about the continuity and the sense of variations? We can say that in both cases f is continuous, but it's sometimes increasing and sometimes decreasing. And what can you say about the nature of I and f of I? In fact, there's no relation between I and f of I. Sometimes they do have the same nature and sometimes they don't. Okay, so do the results of activity 1 and activity 2 work here? In fact, no. So we cannot apply the results of activities 1 and 2 here. They are just applied when f is continuous and strictly monotonic. In other words, f should be strictly increasing or strictly decreasing. So remember, a function f is said to be strictly monotonic on an interval I if f is strictly increasing on I or strictly decreasing on I. Remember also, if x is in the open interval ab, then x would be between a and b. In other words, x would be greater than a and it would be smaller than b. That's why we put a plus and b minus. Now a and b are two real numbers such that a is smaller than b. F is a function defined on an interval I. If f is continuous on I and f is strictly monotonic on I, then I and f of I have the same nature. This is what we said before. Well, specifically, if f is strictly increasing and I is semi-open or semi-closed, AB, then we can say that the image of I or f of I is f of A and the limit as x tends to b minus. Whereas if f is strictly decreasing, we can say that f of I is the limit as x tends to b plus and then f of A closed, so we flip the boundaries. We can also say that if f is not strictly monotonic, then nothing could be said. In this case, we divide the interval I into subintervals where f is strictly monotonic on each of these subintervals. Let's see this application. We need to complete the table below by writing the correct interval. F in this case is a function whose domain is I and range is f of I. Now try to do it alone. Okay, another application, we have this table of variations and C is the representative curve of the function f. The question is to prove that C has a limiting point whose coordinates are to be determined. The limit, as you see, as x tends to 1 minus is 5 and the limit as x tends to 1 plus is 5, so we can say that E15 is a limiting point. Now write an equation of t, the tangent to C at the point with abscissa 2. This is 2. When x is 2, we see that f of x is 4, so a is 2, 4. We still need the derivative at 2, so f prime of 2 in this case is 0. When x is 2, f prime is 0. We know everything, we just substitute. We get y equals 4 is an equation of t. Now find the image of each of the following intervals. So this is I from negative infinity to 0. We need its image. This would be its image. Let's see how do we write it. On I, f is continuous and strictly increasing as you see. So if this is I, f of I would be the limit at minus infinity and f of 0. Because it's closed at 0, we just apply an f, and because it's opened at negative infinity, we put a limit. And the limit when x tends to minus infinity is negative infinity, and f of 0 is 0 from the table. Now let's see it on another interval. The second interval is the semi-open or semi-closed interval 1, 2. From 1 to 2, the function in this case is decreasing. we use the same procedure. F is continuous and strictly decreasing. So if this is a j, f of a j would be f of 2, and the limit, we flip the boundaries because the function is strictly decreasing, and f of 2 is 4. This is 4, and the limit as x tends to 1 plus, this is 1 plus, is 5. Remember, this is 1, so in this case, we don't take f of 1, we take the limit as x tends to 1 plus. Okay, a third interval, which is 1 plus infinity. So we see here from 1 to plus infinity, the function is continuous, but it's not strictly monotonic. So we divide it into two parts. It's going to be from 1 to 2, union 2 plus infinity. Remember, dear students, here that this interval should be equal to that one. So if it's closed at 2, let it be opened at 2 here. And then we find the image of each interval alone, and finally we find their union using the number line. Let's see how. F of 1, 2, this is 1, 2. Its image would be the interval 4, 5. This is 4, 5. You see, this is semi-open, this is also semi-open, but the boundaries change because the function is decreasing, is strictly decreasing. And f of 2, 2 positive infinity, this is 2 positive infinity, its image would be 4, 7, open interval. Then we need their union. We draw the number line. The numbers that exist are 5, 7, and 4. So for the first interval, it's closed at 4 and opened at 5. This would be the first case. The second case, it's opened at 4 and opened at 7. Remember, in case of the union, we have to take all the numbers that exist. So the whole would be from 4 closed to 7 opened. So in general, if it's strictly increasing or strictly decreasing, we either apply an f or a limit, and don't forget to flip the boundaries if the function is strictly decreasing. Whereas if the function is not strictly monotonic, it's sometimes increasing, sometimes decreasing, we have to divide the interval into some subintervals such that the function is strictly monotonic on each of these intervals. Mira or Rami? Let's see. The table at right is the table of variations of a function f, and the question is to find the domain of definition and range of f. This is very simple. Let's see, Mira. The domain of definition, which is represented by I, is negative infinity, 0, union 0 plus infinity. And the range is from minus infinity to plus infinity, since the minimum is negative infinity and the maximum is positive infinity. Let's see Rami. The same domain for Rami. And the range is f of negative infinity 0 union f of 0 plus infinity. So Rami divided the interval into two subintervals, and he found f of negative infinity 0, which is 2 plus infinity. This is 2 plus infinity. And f of 0 positive infinity, which is negative infinity 0. And then he tried to find the union of these two intervals. Numbers that exist are 0 and 2. So you see, this is from negative infinity to 0, and this one is from 2 to positive infinity. And in fact, the two intervals do not overlap, and the answer would be the same interval, which is negative infinity 0 union 2 plus infinity. Now, which method do you prefer and why? I think Rami's method is correct. Mira's method is not correct because f of x doesn't take any value between 0 and 2. Thank you.